Earlier we did a research of drying nylon filament segments at different temperatures. But how does it compare to the drying the whole spool? Let's find out. Welcome back to my tech fun. This is one of those videos where probably I will lose subscribers, but believe it or not, this is part of my tech fun. A few months ago I presented our research on university when we dried a nylon. But in that work we dried only piece of filaments, and I got some suggestions to try all this with the spools too before we write the final scientific article. So that work is finished too, and part of the results I decided to present in this video. This video and all my research is sponsored by Polymaker, who became a channel sponsor. Okay, let's see drying at 70 degrees Celsius. As a practical application, we dry the filaments under the following conditions. Polymaker PA6GF. It was dried using the Sovol SV02 filament dryer at 70 degrees Celsius, which is the maximum drying temperature for this device. The filament was stored in a resealable bag for almost 2 years. Average relative humidity is around 45–50%, and theoretical maximum temperature for this spool is 100 degrees Celsius for the glue. For drying at 95 degrees Celsius, we used the Polymaker PA6CF, and it was dried in a kitchen oven set to 95 degrees Celsius. Now at that time I didn't have a filament dryer which can dry on this temperature. Now I have the Sovol E2, but it is a prototype and very inaccurate. The maximum drying temperature is the same, 100 degrees Celsius because of the glue, and it was stored together with the PA6GF. For drying at 120 degrees Celsius, we used the Bebele PPA-CF. It was dried in a kitchen oven set to 120 degrees Celsius, and this was the only filament, nylon type, which can be dried on these higher temperatures. Maybe off topic, but spool is very important, and Creality, I'm talking to you now. For example, PPA-CF spool, here you can see it before the drying, and here you can see it after very short drying on approximately 90–95 degrees Celsius. It completely changed the color, even the sticker and the spool itself. So for this kind of nylons, definitely pay attention, dear manufacturers, to place it on the spool which can be dried on these higher temperatures. The scale, I used the Weber analytical balance with the maximum capacity of 2 kilograms and precision 0.01 grams, and it was presented in a separate video. And now about the method. I will present here detailedly the drying at 95 degrees Celsius. Here you can see the measured points in the function of the time, the mass in grams. And if we align this 4PL equation, this means we have to find this ABCD numbers constants. We will get this function, and in this case these numbers. And you don't have to be expert to this. I use the solver in the Excel, but for example you can use online services like MyCurveFit. Here you can see if you have the measured points, you can enter the data, and all these numbers you will get from this website. And the most important here is the D. It's a so-called minimum asymptote. Theoretically, in infinity, this will become very close to this line. Actually, it is aligned on this line. And this is the theoretical drying mass. In this case, 511 grams approximately. Now, if we take that 5% of the moisture is suitable for the printing, which I explained in that earlier video, in that case, we can even see that the line for this drying time was 4 hours. Now let's see the 70 degrees Celsius drying. These are the measured points, and this is almost linear, but even here I could align those points. And the D is in this case 616, but with very big inaccuracy because it was extremely far from that constant line. And even if I add 5% of the moisture, it is really far on this scale. But the drying time can still be calculated, and in this case it was 61 hours, which is approximately 2.5 days. And now let's see the drying on 120 degrees Celsius. In this case, this 5% moisture was 952 grams, and the drying time was 2 hours. It is even visible on this graph. This is the summary. Maybe this column is the most important. Time to reach those 0.5% of the moisture. on 70 2.5 days, on 95 4 hours, and 122 hours. Of course, don't forget this is different type of the nylon, a little bit hard probably for the drying, but less sensitive compared to the PS6. But even then, these are quite realistic numbers. Actually very similar which we got with the drying of those piece of filaments. Now, there is a huge difference in drying time between 70 and 95 degrees Celsius. And the reason for this is that don't forget 95 degrees Celsius is very close to the boiling temperature. And at this temperature, those water molecules became very active. Now, don't underestimate drying on 70 degrees Celsius too, because 12 hours of drying on 70 degrees Celsius can help too. Better than nothing. But it is extremely important to continue the printing from the filament dryer. In worst case, we can experience a lot of stringing. Not so obvious problem is the over-extrusion, since micro water drops will boil in the nozzle and push out more material, resulting very ugly surface and bigger dimensions. This is my calculation in the Excel table, and pay attention to the R square, how accurate is the aligning of the equation to the measured points. And I will upload this table to my Patreon page if somebody needs it. How I imagine the perfect filament dryer. Maybe I should talk about this in a separate video, but I've decided to include here a short version. Maximal drying temperature very close to those 95 degrees Celsius I mentioned earlier. Rotating of the spool during the drying, I think this is extremely important, especially on these higher temperatures. If humidity becomes too big, let out the moisture. And I wouldn't even dare to suggest this if I don't know that somebody already did, Bamble with their new AMS unit. So it is possible, not so complicated, and extremely useful. If not, then at least we need some holes and constantly let out the moisture from the dryer. Inbuilt scale to determine if the filament is dry or not. Wouldn't it be great if we place a filament in the dryer and we can dry it until it's not dried? And with the scale we can know when it is ready for the printing. We don't need a calibrated scale, just relative to the start weight. This means if I place a filament inside, we don't need to know that it is exactly 900.72 grams exactly, and this is the accurate. It can be inaccurate a little bit, but relative to that weight, by time, the change has to be recorded. And with some basic math, which can be done by the dryer, not by the user, we can know if the filament or when will the filament be ready for the printing. Before I got too many comments that this is some kind of scientific friction request or whatever, this is something realistic. For example, Care Moisture Analyzer, which we used in my previous video, works exactly on this principle. It is a dryer with very precise scale, which is even calibrated. Or for example, the Esan e-box. Do you know that that first version, which I presented maybe 4 years ago, had a scale in it? Of course, it was not too accurate, and mostly it was to see how much filament we have on the spool, but if it would be more accurate, basically, it can be used to determine how much dried is the filament, for example. And then we have some other obvious things. First, about the size. I'm not sure, and maybe you can help me, or maybe we can together help to the companies to see which is the optimal size. For example, space for 2 spools, or one wider or bigger spool, that's one suggestion. Or only one standard spool. It is easier for heating because we have less unused air inside. Round the top surface, which is so obvious with the old filament dryers because we have less unused volume inside. Thermal insulation, again, early dryers had it and somehow they forget or I don't know, it's too expensive or whatever. So in nowadays filament dryers we don't have this thermal insulation. It should be transparent, the top, so we can detect any possible problems, tangle or something like that. Smooth exit of the filaments and many other things which are so obvious, but somehow, as I mentioned, they forgot in new dryers. Well, that would be it. Thank you for your attention, and please let me know down in the comments how understandable was this presentation. And huge thanks to all my Patreon supporters and to the Polymaker, because with their donation and sponsoring I can do this kind of research too without any problems. And to all you others, thank you for watching this video and happy printing and drying. See you.